Okay, good morning, everyone. This is Jason Vandiver, Energy Code Program Manager for SPEAR. Thank you for joining us this morning. I do see a couple of folks have raised their hands. If you'll just type in your questions, any kind of questions, type them into the question and answer panel. Be happy to take care of all those at the end of the presentation this morning. I'll look at those when I turn it over to Robbie, just in case something is imperative for this morning. I did want to show you folks, we do have a few city efficiency leadership roundtable. We have one for Central Texas and the Gulf Coast coming up. Also, a PACE for Local Governments webinar coming up with Doug Taylor, a really good speaker. That should be a really interesting one. And then greenhouse gas inventory basics. All of these are run through from Cassidy at SPEAR on our city side at SPEAR. Just so a way to get there, if you go to eepartnership.org and go to events, and on our events calendar, you can register for all of those. Here's our webinar this morning, how to read. Most of you folks that are joining us for our codes webinars, you get that weekly email. Next week will be, there's no such thing as a ton. That invite will go out tomorrow. I'll put that on the calendar tomorrow. But you see Cassidy's here. She's a little more proactive than me. She has her next 3 weeks already scheduled. I run a little bit looser operation, needless to say. But fantastic speaker with us this morning. I'll go ahead and stop sharing, Robbie. If you want to go ahead and start your screen share, you can. Robbie Schwartz with Build Tank. As far as residential international energy conservation code goes, I will put Robbie up against just about anybody in the country. He certainly knows what he's talking about, and he cares that the code says what it should say. He is consistently suggesting code changes. He's at the code hearings. He's a guy that knows the code and knows what's broken in the code and tries to get it fixed. His presentation this morning, it will be about how to read IECC reports and what you need for compliance. A little something personal, Robbie. What's your favorite movie or book? And then introduce yourself and get started.
Hi, this is Robbie Schwartz. My favorite book, I think, is Watership Down. Love that adventure those rabbits took. That's what popped in my brain there. Thanks so much for having me. Thanks everybody for joining us today during these difficult times. It's great to gather as a group and be able to talk for a little bit. Again, my name is Robbie Schwartz. I'm formerly with Energy Logic. As of January, I started Build Tank. The idea of Build Tank is that it's a pragmatic building think tank that's using the things that we learn in the field to try to move our industry forward. And to that end, like Jason was saying, I do a lot of work in the code development world to try to move things forward. Today we're going to be talking about reading ICC reports. If I can get everyone, I'm pretty sure everyone already has muted themselves, but please type stuff in, and at the end here, with Jason's help, we'll go through any questions that come up here. Okay, so our plan today is to talk about the construction documents versus what we call compliance documents, make sure we have a good understanding between the two. We'll talk about the different compliance pathways and the compliance reports that go with those different pathways, other compliance reports, and then ultimately how field inspections fit into all of this here. As we know, jurisdictions are out there working with builders and developers to build houses. They have to look at a lot of things, and we also know that they're really not able to look at everything that the code is asking them to look for. So if we can look at and understand the compliance reports, we'll have a way to work our way through code and ensure that these houses are being built and built properly, with potentially not having to look at every single thing in the field that we don't have time to or don't understand per se. Now, the Department of Energy has a codes program, and they put out a document that you can see there on the right. And they talk about 10 steps that we need to focus on for successful compliance, beginning with knowing which code is applicable for that particular project. That's really interesting for a state like Colorado, where I'm based in. Being a home rule state, each jurisdiction is basically on a different code. So in the Denver metro area, we have about 30 plus jurisdictions. Each jurisdiction is doing their own thing. So it's very important to know which codes you're working with there. Choose the compliance path within that applicable code. Know the requirements of that applicable energy code and that pathway. Design a building to meet the requirements of the applicable energy code. Document the design of the building in the plans and specifications, and we'll also add their compliance reports. Construct the building to meet the specifications, and then document that the as-built building is actually built per those specifications. And then ensure that the as-built building performs and operates as ultimately intended. Not all of the pathways require formal documentation that the house performs. They rely on inspection to be able to do that. We need to provide the energy code compliance documentations to the code officials that are required at plans and for the CO for that particular house. And then get assistance when you need it. And there's lots of avenues to get assistance from SPEAR, from energy raters, from code officials themselves. There's lots of people that are willing and able to help you in this process. When we start diving into the code itself in Chapter 1 of the IECC, we see that construction documents and the technical reports shall be submitted, and with each permit application for that particular house. The construction documents and technical reports also shall be prepared by a registered design professional. So it's important to understand that this section is talking about those construction documents and technical reports. They're talking about the plan set that is used to create and build that specific home from. But there's this whole other set of documents there that have to be looked at too, and those are called compliance documents, and we'll get to those in just a minute here. What we see is that construction documents are developed to help the contractor understand the accurate implementation of the design. So these construction documents are multi-page documents. They include site plans and window schedules and sectional drawings, other extensive details on how to flash window openings, for example. They're very important documents, but we also need to understand that they're not the same thing as compliance documents. These construction documents in and of themselves don't necessarily show that a home is compliant with the energy code. So compliance documents are not really discussed in the IECC, and specifically not in Chapter 1. They're in other chapters of the IECC. The DOE says that we need to provide these documents to the code officials, yet most registered design professionals aren't the ones that are actually creating these compliance documents. And we need to understand that it's a crucial step in ensuring code compliance, not only before the house begins, but in some cases to actually be able to issue that certificate of occupancy. We need to have that compliance document there. So we need to submit the compliance document at the proper time, and ultimately that compliance document needs to be reviewed before the house continues in its process to get its final certificate of occupancy. So the types of compliance documents that we're talking about would be an area-weighted U-value res check report, or there are other softwares that we'll talk about here in a moment that develop that area-weighted compliance document. The cost compliance report for the simulated performance path, the energy rating index report for the ERI pathway through the code. We need to understand the difference between proposed and confirmed reports that are returned in at the process of permitting the house versus turned in at the process for getting the certificate of occupancy for the house. And then other compliance reports are basically documenting testing that happens on the house air leakage and duct leakage reports, and we'll look at all of these in a little bit more detail. So again, going back to Chapter 1 of the IECC, we see that the construction documents need to be prepared by that design professional, and that these documents need to include all these things that are listed on the right side of this slide: insulation, location, and R values, mechanical systems design criteria, duct sealing, insulation, and location. And then what was added in the, I believe, the 2015 IECC cycle were these air sealing details. Now, these air sealing details are super important to have in your construction documents. They look like this so that they can be executed properly in the field. We ultimately want things that are on those construction documents as guidance for how to do things in the field. So to get that air barrier behind the tub on the exterior wall, to put an air barrier up on the bottom cord of a truss and on that exterior wall, so that drop ceiling where the can light is located is all within the conditioned space of the house. Those are requirements of the code. These details help that implementation in the field, and then as an inspector, we can go and look and ensure that those things are taking place properly. Another thing that was added in the 2015 IECC was this section of the code that says that the building thermal envelope shall be represented on the construction document. Now, this is just one example of how you might be able to do that, but again, it's super important to have this depiction on the construction documents so that when it gets out into the field, the people that are actually constructing the house have an idea of what the designers intended, where that thermal envelope is. And we also need to understand at this stage that the IECC is super hyper focused on the thermal envelope and ensuring that that thermal envelope is executed properly, because so many things from a performance perspective are dependent on that thermal envelope. Not only comfort and efficiency, but remember that that HVAC design that's done before the house is built will not work unless that thermal envelope has been executed properly out there. So we want to make sure that that is done well. Now, if we move on to Chapter 4 of the IECC, we see the different pathways of compliance are talked about in this section here. We have the prescriptive path, and within the prescriptive path, the UA trade-off path is part of that prescriptive path, but I like to break that out separately because this section of code, the UA trade-off pathway, utilizes software, and the true prescriptive path just utilizes the R value and U value cable there. So we're going to talk about 4 compliance pathways: the prescriptive pathway, the UA trade-off pathway, the simulated performance pathway, and the energy rating index pathway, and talk about the different compliance reports that are needed for these different pathways. So if we begin with the prescriptive pathway, we see that it's the most restrictive pathway. Your only option is to do better than what outlined in the R value table, which we'll see in a second here. There's no true compliance tool for this. It's just a declaration that you make on your permit set of construction documents there. So this is the table that most people are using for their prescriptive compliance. I'm in climate zone 5, so I'll use climate zone 5 as the example here. But what we need to know is that first, you have to do better than. You can't trade off worse than. So for example, in ceilings here, it says in climate zone 5, you have to install an R49 attic insulation. I can't install an R38 or an R30 in this climate zone if I choose to use this pathway. It's a declaration that I'm doing this. I can install an R60 if I want to, but I can't go below. The other thing to know is that those R values are talking about cavity insulation only. It's not talking about an assembly of things. So if we move over to the walls, we see that an R20 wall cavity insulation needs to be installed. I can't go below R20, but I could go above R20 in this pathway here. And again, the compliance document is the declaration that's made to the code official through your construction documents there, basically. So what we're starting to see now is that an energy page is being added to our construction documents to be able to fully declare that you're using this prescriptive path. The reality is that this type of energy page is being used for all the compliance pathways. And in the 2021 IECC, there were proposals that passed that say that you have to formally declare the compliance pathway at the time of permitting, which is not actually required right now. Some jurisdictions might require it, but on a national scale, it's not required. So this type of energy page, we're going to break down and show you the different pieces here and how it helps demonstrate compliance here. So first, here's an example of the depiction of the thermal envelope of the house. You see the blue lines and different lines here so that we can get an idea of where the architect or designer wants that thermal envelope to be. So most often you'll see it on the sectional drawings of the house. These are air sealing details. This happens to be a Department of Energy air sealing poster that some builders or designers are adapting and using in their construction documents because it has all the main details that are talked about in the air barrier and insulation table there. Here's just a simple Excel document that documents all the R values and U values. These have to be in alignment with the insulation R value table of the code, what mechanical systems are in that house, what types of windows are in that house, and then if you're using third parties at all, potentially a signature would be needed. And then there's some written part of this particular compliance document or code sheet in the plan set that is talking about other mandatory features of the code. You know, do you realize that 2 or 3 stud corners are a mandatory requirement of the code? That insulated headers are a mandatory requirement of the code. This designer wanted to ensure that that information got out into the field and that their plan set documented that so that they, to some extent, covered themselves, but also ensured that that knowledge got into the field and things got implemented correctly in the field here. So again, an energy sheet on your plan set can make a lot of sense, a good way of transferring information, but some of these things are mandatory requirements, like the depiction of the thermal envelope on the code. Now, the U-factor alternative pathway in the code is unique for a couple of reasons. First of all, it's talking about an assembly of things. The U-factor that are in these tables is depicting an assembly U value instead of a cavity R value. But what I want to demonstrate in this particular slide is that they're equivalent to each other. The R value in the R value table and the U value in the U value table are equivalent to each other. And I'm going to use the wall framing U value here as an example of that. So if you take the reciprocal of the U value, you get the R value. So in this case, the 0.06 is equal to about an R17 wall. And if you take the reciprocal of the R20 from the R value table, you get a 0.05. So the difference between the 0.05 and the 0.06 in the U value table is the different layers there, the sheathing, the air films, all those other things give you that 1/100th of a U value there. Another way to look at that, if you look at a modeling software, this comes from the Ecotrope software, you see that the layer path here is starting with the sheetrock layer, the cavity layer, in this case, fiberglass R20 wall that's framed at 16 inches on center. You have your OSB layer, you have your weather resistant layer, you have your siding layers, and then the airspace layers are also incorporated in here. But you see that the R20 cavity insulation is different than the whole wall R value situation. So it's closer to that R17, which is, if you take the reciprocal of that, is that 0.06 U value that's in the U value table. So the reality of the U value table is that the U value table is needed in order to do software calculations. You can't basically do the mathematics that you need to do in software using R values. You have to convert those to U values, and that's really why that U value table is there. And all these other pathways in the code are using softwares. The UA compliance pathway is using software, the simulated performance path, and the energy rating index pathway are all using softwares there. And how do the softwares work? Well, ultimately, the softwares are trying to determine a delta T location. Delta T is the temperature difference. And in essence, what softwares are trying to do is create a temperature difference between inside the house that's defined by the thermal envelope to outside the house, to ambient conditions outside the house. So the software describes the thermal envelope and its location, delta T, to ambient air and dirt. And every building component is entered into the software, and its location with regard to ambient dirt or ambient air, or what we call buffer spaces, is input into the software. This describes ultimately our heat loss or heat gain. Remember, heat is always moving from warm to cold there. So that's ultimately what the softwares are doing. So the softwares continue by creating a reference home. So the software creates a reference home, and the reference home is compared to the home that we're actually rating or looking at from a code compliance perspective. The reference home is defined as a standard set of house specifications that generate a specific, consistent, and quantifiable energy performance. And that consistent, specific, and quantifiable energy performance is defined by the code there, and for this case here. However, there are different types of reference homes. There are reference homes for the UA compliance path, the simulated performance path, the ERI pathway. There's also a ResNet HERS ERI reference home. There's an Energy Star reference home. Building programs through utility programs have user-defined reference homes. But ultimately, what's happening is you have, if we look at the picture here, you have the rated home. The rated home is a geometric twin of the reference home, and the rated home is compared to the reference home to demonstrate compliance there. So how that is done is what we call the twin house concept here. So we have the reference home compared to the builder's home in this specific case. So again, these two houses inside the softwares are geometric twins of each other. All the geometry is used, entered once, but two houses are basically being created inside the software that are geometric twins of each other. The reference home is overlaid with the IECC prescriptive envelope R values. The builder's house is using whatever the builder specifications are for that house. And to demonstrate compliance, the builder's house has to be less than or equal to the energy performance of the reference home in order to meet the intent of the code. So how do you do that? You use the software. So for the total UA alternative pathway, there happens to be 3 or more softwares. These are the 3 main softwares that are out there that can demonstrate compliance. The ResCheck software, RemRate, and Ecotrope all do that. We often call these reports a ResCheck report, but the reality is that ResCheck is the software, not the compliance report. But I'm going to start with the ResCheck report and look at what we need to look at if you're going to get this report for the area weighted U value compliance metric. So the first thing we need to know is what code we're working with. So in this case, we're working with the 2012 IECC. We need to know that ResCheck only supports the last 3 editions of the code. So the 2012 will fall off as the 2021 cycle comes on here. So you're not going to be able to use ResCheck for older codes, which is basically an incentive for jurisdictions to keep moving forward here. We want to double check the locations and conditioned floor area, glazing, all these different things that are talked about in the project information. But ultimately, this first page is telling us if this house complies or not, and it showing that compliance here if it passes or fails the UA trade-off pass. So I've blown that section up here. This house is passed at 3.2% better than code. We have the maximum area weighted U value for the reference home, which is at 375. Your house or the builder's house is at 363. So the builder's house or your house is less than or equal to the maximum allowed area weighted U value, therefore it passes code. And again, in this case, it's 3.2% better than code. And that's where you demonstrate that compliance. That's not all that we need to look at, however. We want to make sure that they created this report well. So we want to look at some of the envelope inputs that were done for this report. So we can look at the envelope assemblies here. and see what different features they used in that assembly here. So for example, if this house had a vented crawl space, then the crawl space would not be part of the building envelope and should not be shown on the report, because your thermal boundary would be defined as the floor system above the vented crawl space. So those types of things should be looked at and reviewed at when you're looking at this compliance document. Next, you might look at the gross areas to make sure that they did their takeoffs right or didn't make a mistake when they were typing it into the system here. So for example, the ceiling, flat ceiling or scissor truss ceiling is 1,400 square feet. What if they accidentally put in 14,000 square feet? That could make a big difference in compliance. So you want to double check quickly that their takeoffs were within range. They don't have to be exactly, different people. If you had 9 people doing takeoffs, you'll probably get 9 slightly different answers, but they need to be within reason there in essence. Next, we want to verify the R values and U values that they entered here. When you enter the R values, they get converted into U values. Unless you're entering window U values, they just stay as U values. But ultimately, you want to verify the R values shown on the building plans meet the R values that are being depicted here on the compliance report here. What's interesting here is how things are entered into the different softwares. So this is a flat ceiling ventilated attic. So there is some cavity insulation and some continuous insulation. So from the bottom cord of the truss, in this case was a 2x4 bottom cord of the truss, that blown insulation that fills that cavity between the bottom cords of the trusses, that would be cavity insulation. And then the insulation that covers up the bottom cord of the truss, that would be continuous insulation. And in this case, they have a total R49 installed in that attic, and you can see how it gets converted into the U value there as well. So the next thing that you would check would be those U values to make sure that that happened correctly in the software calculation there. And you could also look specifically at windows, because windows obviously are only entered as a U value there as well. Now, as I was saying before, ResCheck is one of many softwares that can create these UA compliance reports. So what I've put up on the screen here are compliance reports for the UA compliance path from Ecotrope and from REMRate, 2 other softwares there. These are valid. They can be turned in for compliance of the code. They look a little bit different than ResCheck reports, but they also give all the information that you need, starting with demonstrating that this is a projected report. So in the UA compliance pathway, it only asks for this report to be turned in for permitting. So it's projecting what will be carried out in the field there. So we need to be certain that we're looking for the status, inspection status that's projected on these reports. We have the reference home detailed out here, and what the area weighted U value of the reference home is, and what the designed house is, or the builder's house here. We're looking for the designed house to have a lower or equal area weighted U value to the reference home. In both these cases, that's true. And in both these cases, we see that they document that the house, the as designed house, meets or exceeds the requirements of the prescriptive compliance path using area weighted U values here. Now, what this report doesn't do is it doesn't give you the details of the assemblies that are used to demonstrate compliance. So you're going to have to get a separate report. And the code calls for an energy code inspection checklist that gives you that information. And so from these softwares, all of them, you can get an energy code inspection checklist. This is just an example of that checklist. So the checklist gives the property information. It also gives the status again. It's the results of that this is a projected report, that it's not, hasn't been confirmed out in the field. It also gives organizational information there, who actually created these reports. Then it gives general building information. Again, this might be something that you want to confirm that the conditioned floor area and the volume are within range to what you might get when you do a takeoff of the house there. This section I'm going to blow up and read because it's interesting and not a lot of people see that actually spend the time to look at it on these compliance reports. This says that the building's energy modeled in Ecotrope reflects the building assemblies and energy features listed below. Sometimes energy features will change in the field from what has been modeled. The inspection process should identify any changes and ensure that the home continues to meet the applicable energy code. We see that often in houses, especially with windows or sometimes even with insulation in different components of the cavity. So again, this being a proposed document, you have to wed this document with your field inspection to be able to ensure that you're getting a compliant house there, because things might change. They might say that they're putting in a 0.34 window in the home. You go out there for inspection, you actually see that the predominant windows are 0.32. Well, that's better then, so that's okay. But what if they were 0.36? Would that still be compliant with the code? We need to look at that from a field inspection perspective using this pathway in the code. Now, this checklist goes on and talks about the different components of the checklist, and we'll go into those a little bit detail. I'll blow up those components. In this case, we're talking about slabs, and it gives us an example of the square foot of those envelope components. In framed floors, it gives us an example of the R values that are used in those components. And then we also get indications of cavity and continuous insulation that are used in those different components to demonstrate compliance here. So we can use this checklist in the field to work our way through the house and demonstrate compliance with the area weighted U value pathway. Now, the Energy Code inspection checklist also talks about mechanical systems and mechanical ventilation. If we blow that section up, we see that mechanical ventilation has been modeled in this and needs to be looked at in the field, and the mechanical equipment for heating, cooling, and water heating has been included in this report so that it can be confirmed during inspections out in the field. So these compliance documents not only need to be looked at for permitting, but we need to look at them also when we go out in the field and inspect the house to make sure that they relate to each other there. Okay. Lastly, this inspection checklist looks at air leakage and duct leakage sections of the code. Air leakage now is a mandatory test that has to happen in the code there. Duct leakage is dependent on where the ducts are located, but this section of the checklist is reminding us that we need to look at those reports, those compliance reports, and those compliance reports most likely are going to come at the end of the process. So you're going to need to look at them before the certificate of occupancy is released for that particular house. Okay, so now let's move on to the simulated performance path and look at the reports here. Now, the simulated performance path is also a software pathway through the code. Instead of using annual or area-weighted U values as the compliance metric, it's using annual energy costs as the compliance metric to demonstrate compliance here. So again, the rated house has to have less than or equal to annual energy costs than the proposed house or the reference home for that particular house. Now, the compliance reports are detailed out in more explicit detail in this pathway than in the area-weighted U value prescriptive pathway. The compliance software tool, so generate a report that documents that the proposed design complies with this section of code, but it goes further and says that the compliance reports need to include certain things in order to issue the building permit, and that's in section R405.4.2.1, and then also that you have to submit a compliance report to get your certificate of occupancy, and that's detailed out in section R405.4.2.2. So let's look at these reports a little bit. So basically, these reports are roughly the same that need to be turned in, except for number 3 here. So we have to have that building address and a statement indicating that the design complies. We have to show site-specific energy analysis reports, the name of the people that did the reports, and so forth. But Section 3 for permits says that an inspection checklist needs to be included, and that inspection checklist is pretty similar to the one that we looked at before. But for the certificate of occupancy, it says that a certificate indicating that the building passes, and also that indicates that the energy-saving features of the building have been installed, needs to be included. So that's a little bit different for the proposed and the confirmed reports that have to be submitted there. So remember, proposed reports are everything for permitting. Confirmed reports are reports that take into account what was actually seen on site through inspection, and now it's being reported so that the people that will issue the certificate of occupancy can actually issue the certificate of occupancy. So they need to review those confirmed reports as well here. So compliance reports for the proposed design, showing that it meets. So we have the property information here. We have the status that this is projected for the building permit here. And we also see on this particular report that it shows that it meets or exceeds. So again, we're using annual energy cost, and we have to show that the as-designed annual energy costs, which are shown right here, $1,034, is less than or equal to the reference home at $1,086 there. Therefore, it meets the code. In this case, it's better than 4.8% better than. The certificate indicates that the building passes, which we showed again here, and it indicates that it's confirmed in this case. So the compliance report for the certificate of occupancy is the same report that we showed for permitting, but the status changed. The status is now showing that the results are for a confirmed house, not for a proposed house. So things have been looked at out in the field in that case. Now, it also says that we have to indicate that what the energy saving features are. Now, there isn't in any of the softwares a specific report that the softwares are suggesting that you use to demonstrate that the energy saving features have actually been installed. So I chose the building specification summary sheet report to do that. I think it does a pretty good job of detailing out what the building shell features are, what the mechanicals are, what the lighting equipment are, the size of the house. It does the job that we need to do. You also want to ensure that the inspection status up here doesn't say projected. It should say confirmed up here in order to turn this in for the certificate of occupancy here. But this is a good report to use for that purpose there. Now, compliance reports for permitting, again, the inspection checklist, which we went over earlier, shall show the results of both the standard reference design and the proposed design. So that's a little bit different. So you might turn in the inspection checklist, but you also need to turn in a different report, because the Energy Code inspection checklist doesn't do the second part, the 3B part here, which is asking for looking at the features that were turned in for the reference design and the proposed design. So the softwares have the ability to break out the proposed home summary and the reference home summary that equates there. The proposed home summary and the reference home summary are titled, so you can know the difference between the two reports. And then you're going to have to look at what's actually been put into each location for the R values and U values of that particular report here. So we see that, we'll just blow that up a little bit more here. So we can see that the IECC reference home features were used in the reference home, and the proposed design, in this case, used the 2x6 wall R23 blown fiberglass grade 1 with R5 continuous exterior sheathing in this case. Again, this is for a cold climate, so it's not probably what you're going to see down in Texas there. We see that for glazing, the similar things are looked at. for roof insulation, for whole house infiltration. All of the different components to demonstrate compliance are broken out in these reports for the reference home and the proposed home, and you can see what was used in each of the components. So that's the type of report that the code is specifically looking for from the softwares there, and they're obviously available in the softwares. They just aren't always turned in to be reviewed. Now, the compliance report is looking for site-specific energy analysis report. This is the compliance report for the Certificate of Occupancy. So we have the property address again, we have the name of the individual performing the analysis, and then we have the software tool that's looked at there. So just making that text a little bit larger, we see that this report is generated by the Ecotrope Rater software, and the version number is dictated there as well. The compliance reports, again, need to be broken out for the proposed design. It needs to be submitted for the building permit, and upon completion, the compliance report needs to be submitted for the Certificate of Occupancy to be issued and released here. So projected and confirmed reports, we need to look at this section here. Is it for the projected reports, and has the report been signed? And then this section of the report is another section that a lot of folks don't look, specifically because when you're confirming the house in the field, we need to understand who's actually doing that confirmation in the field. So if a third party is doing this confirmation, we need to understand what this says. So I'm just going to read it out loud here. As a third party extension of the code jurisdiction utilizing these reports, I certify that this energy code compliance document has been created in accordance with the requirements of Chapter 4 of the adopted International Energy Conservation Code in Climate Zone 5 in this particular case. That would be made specific for whatever climate zone the house was being looked at in. If rating is projected, I certify that the building design described herein is consistent with the building plan specifications and other calculations submitted with the building permit application. If the rating is confirmed, I certify that the address referenced above has been inspected, tested, and that the mandatory provisions of the IECC have been installed to meet or exceed the intent of the IECC, or will be verified as such by another party. So this is, again, super important to look at this status up here. Is this for a projected report for the building permit, or is it a confirmed report? And if it's a confirmed report, has it actually been inspected, and has it been inspected in the same way that you as a code official would have inspected it? So if you're using a third party, it's super important to approve that third party and potentially have a scope of work document so that you are both on the same page and understanding how you're going to evaluate that house there. So you can see that this top section here can change from projected to confirmed, and then you utilize the same report to demonstrate compliance here. Okay, energy rating index pathway. The energy rating index pathway, so the first thing that we need to understand is that the energy rating index is not the same as a HERS or ResNet energy rating index there. So we have to be particular about our language. We need to use adjectives to describe the type of energy rating index. When code adopted the energy rating index, they did that because ResNet's HERS index is a proprietary term, so they're not going to use HERS index. We also need to understand that the index has changed from the 2015 to the 2018 to now to the 2021 cycle. So we need to use that modifier that says we're talking about the 2018 energy rating index in this case, not a HERS index, not the 2015, and not the 2021 index pathway. These are the scores that were required by the two different codes that are currently out there, the 2015 and the 2018. You can see that the scores are different there, but if you did a HERS index for a house that was complying with the 2018 energy rating index pathway, you would see that the HERS index, the HERS energy rating index, can also be different. And I've seen it be different by as much as about 18 points than the code energy rating index. So that's important to know that you're talking about the correct energy rating index here. What we see for compliance is this section R406.4. It says compliance based on an energy rating analysis requires that the rated design be shown to have an ERI that is less than or equal to the appropriate value listed in the table. And the table is what's above here. So in Climate Zone 5 that I built in here in Colorado, for the 2018 IECC, I have to have an energy rating index that's less than or equal to 61 to demonstrate compliance, as well as do all the other mandatory aspects of the code here. So the compliance software tools, the code goes into a little bit more detail here that says that they shall generate a report that documents that the energy rating index of the rated design complies with the section that we just talked about. It also needs to list out the address. It needs to provide an inspection checklist. And it also needs to show that the rated, for the rated design, but also for the reference design as well. So both the ERI reference design and the rated design need to be documented in compliance reports. You have to document the individual who completed the reports and the name and version of the software as well. So this is the true compliance report for the 2018 IECC. Again, this is projected, so it should be turned in for permitting. Right now, the IECC only says that you have to provide one of these reports for permitting. It doesn't say specifically that you have to turn in one confirmed for the issuance of the Certificate of Occupancy. In the 2021 IECC, that will be there. But right now, it's recommended. I would recommend that you get one for permit and also one before you issue this Certificate of Occupancy there. We have the property organization, the people who actually created this document. We have the property address for that document, and then we ultimately show compliance for that. And I just blew that document up as well. It says that this home meets the energy rating index requirements for this section of code. In essence, it scored, it scored 52 in this case without PV. Therefore, that's better than or equal to the 61 that was required in this climate zone. So that needs to be turned in. Okay, we also, the second page of this report talks about all the mandatory features that are required regardless of the pathway that you choose to use. And this report will document those features and if they passed or not. Now, the compliance report is asking for the rated home and reference home documentation here. So that's the documentation that we looked at before, the proposed home summary and the reference home summary reports, and looking at the different specifications for each of the details from foundation, slab, walls, infiltration numbers, duct leakage numbers. All of those things are detailed out in these reports here. And those should be turned in for permitting at minimum, potentially also for Certificate of Occupancy, depending on the jurisdictions there. There is an exception for the compliance report. It says that where an otherwise identical building model is offered in multiple orientations, compliance for any orientation shall be permitted, documenting that the building meets the performance requirements in each of the 4 primary cardinal directions here. So in essence, if you build Plan A 100 times in a specific community, you don't need to turn it in 100 times. You can turn it in the 4 cardinal directions and demonstrate compliance for permitting purposes here. Additional documentation, again, the code official always has the right to ask for additional documentation, and these are some examples of that documentation: the reference design and the rated design, which we showed you, and so forth and so on. I'll let you read that here because I needed a drink. Okay, other reports needed to document compliance. Let's look at those real quick. Chapter 3 talks about needing documentation to prove what's actually been installed from an R value perspective. So we shall provide a certificate listing the type, the manufacturer, and R value of the insulation installed, specifically for insulation that doesn't come with an R value mark. This is very, very important. Right now, it doesn't tell you specifically when this document needs to be provided, but I always recommend that it's provided at the time of installation of the insulation, especially if you're blowing your walls with insulation, for example. Who knows what the R value of that blow is? So in essence, the installer is certifying with these types of documents what the R value is. And also certifying that they've installed it according to manufacturer's instructions, the density that the manufacturer is requiring there. So this is a very important report to look at, especially now since we have so many materials that are installed that we don't know what the R value is. There's no R value mark on the material there. Certificates, it says in Chapter 4 that a different certificate needs to be completed and posted it says here in the electrical distribution panel, but we're seeing most people want it installed in a prominent location. This certificate needs to detail out the R values and U values of the building thermal envelope, the results of duct leakage and building leakage testing, the types and efficiency of the heating and cooling systems, and it's required regardless of the compliance path that is used. And this certificate will look like this, showing all the different components that we just called out on the previous slide here. Again, we're seeing most jurisdictions looking for this in a prominent location. For example, down by the furnace cabinet. It often doesn't come in a sticker format, although it's printed out by the softwares that are doing compliance-based software compliance. So we're seeing builders often cut this out and then tape it on with clear packing tape onto the furnace cabinet or somewhere near there, for example. Now, by saying that, there isn't a way to create this certificate for the prescriptive path of the code, although it's also required for the prescriptive path of the code. So we're getting all kinds of handmade certificates right now for that pathway of the code there. But you do need to look for it. And then you need your testing reports for your blower door test to ensure that it passed. This report needs to be looked at before a certificate of occupancy is released. We're seeing, unfortunately, some jurisdictions that aren't looking for it, and some jurisdictions that are issuing certificate of occupancy for houses that haven't passed. This is one area or one example of a report where that information shows up on this overall certificate that shows that the house passed the document. There are specific air leakage reports from softwares that demonstrate the compliance of this house. This house achieved 3 air changes. Again, it's a proposed report, projected report. So you want this report for the certificate of occupancy to say confirmed on it, not proposed there. I guess I changed that there. This is an automated testing report from the manufacturer of the blower door testing device. This is a good report to look at as well. So there are a variety of different reports that you could look at to demonstrate compliance with the air leakage requirements of the code. A written report has to be given for duct leakage testing as well, if that's a part of the code. So again, is it projected or is it confirmed? You want to make sure that you have a confirmed report. It gives you the duct leakage testing results here. And then in this case, it also gives you the mechanical ventilation testing, although that's not required right now. In the 2021 cycle, it will be required to actually measure mechanical ventilation and all ventilation in the house as well. The Energy Rating Index is an interesting report that often is turned in, although it's not a code compliance report. I just wanted to make sure that everybody had a common understanding of the energy rating index. So like a golf score, the lower the score, the better. You can think of it as a miles per gallon rating system for homes, so you can compare homes of different sizes and shapes there. The reference home is equivalent to a home that was built to the 2006 IECC and a house that scores 100 on the scale. A HERS index of 0 is a net zero home, a home that produces as much energy as it actually uses there. And the DOE has done some research to confirm that a house that scores 130 on the scale is equivalent to basically the average existing home out there in the market today. So the energy rating index certificate, or the home energy rating certificate, again, is not a code compliance document, but it gives you some very valuable information. First of all, has this house been confirmed and registered in the National ResNet Home Energy Rating Registry? If it has, you can get additional information that I'll show you in a second. That's one way to show that this is a confirmed report, although it says it there as well. This gives you the HERS index, or the HERS energy rating index for that house. Remember, it's not the same as the code energy rating index. It gives you annual energy savings compared to that average existing home if this house was scoring 130 on the scale. It gives you estimated annual energy use and energy costs for that house based off of a yearly usage. You can divide that usage by 12 and get a monthly usage estimate for that house. It gives you the energy features in that house, which are good to look at as well. And then if this house meets or exceeds any codes or programs as well. This report would be signed by the energy rater who issued it. It's important to remember that this report is not a code compliant report. You would be if this house used an energy rating index for code compliance, you would be using the ERI report that I showed you earlier, not this report. But generally speaking, this report is given to the builders, and the builders often give it to the code official, so I wanted to make sure that you saw that. Now, if this home is registered with the ResNet system, you can get all of this information from the registry itself. If you go to this website and type in the name of the rater, you can get information about the rater who did it, what type of standing they are with ResNet. Are they in good standing? Are they in probation with ResNet? What's going on with that rater? So this is important to know how to get to there. You can also get public access information about some of the information of this house, like the address and who rated the house and what the HERS index score is for that house, going to a slightly different website there. Both of these websites are accessible through the ResNet website if you don't have time to look at this. We'll also be handing out the slides so you can get to that information as well. So the last document that I want to talk about here is what's needed for the thermal envelope and HVAC design here. Now, all of the compliance that we've done here is trying to ensure that our thermal envelope is sound, and therefore that our HVAC design, which is done before construction, is also going to work here. So we have an assumption that our houses, and we have a goal that our houses have consistent temperature from room to room and floor to floor, and that we're not going to be building a poorly insulated house that is just pumping in lots of energy into that house, but that we have right-sized our systems to work with the thermal envelope that we propose to build. So it's super important to ensure that the envelope that we propose to build actually was carried out in the field there. So we need to look at the HVAC design again and see what was done at the design stage. That means that we've calculated the heating cooling loads for that house, that we've selected the equipment that has capacity to meet those loads, and that we've designed a duct system to deliver those loads around the houses there. So we need to look at that HVAC design and at a minimum look at these 6 things. And there are actually a lot of other things that we should look at, but at a minimum we need to make sure that the indoor design temperatures and the outdoor design temperatures are correct for that particular environment, climate zone that we're building in, that the square footage of the house of the building envelope components are within reason, and that the R values and U values of the components match what was proposed for that particular house, that infiltration and ventilation rates were taken into account properly so that we're not oversizing or undersizing the equipment, and then ultimately the orientation is correct for that particular design, especially if it's a custom home there. So these are some of the things that we need to look at from an HVAC design perspective, and that compliance report that's turned in for permitting there. And then we need to carry out things in the field and ensure that the inspections that are called out in Chapter 1 are actually carried out in relationship to what we learned from those proposed compliance documents here. Now, the code takes these inspections, they break them down in a little bit more detail and say at a framing stage, for example, that we have to look at the R values and their correct location and proper installation. We need to look at air leakage controls and requirements of the code. From a mechanical section, we need to look at the required controls and system installation and corresponding R values, the system air leakage controls, and whole house ventilation as well. So these things are called out specifically that we need to look at. This whole idea of performance and how houses work is being wrapped into that inspection process. So in essence, when we go out into the field, we're looking and trying to understand, is the component that we're looking for actually there? So in this case, the fan, the ventilation fan to get moisture up and out of this bathroom at the time it's being produced, is that fan there? And then we need to couple that with another question when we're doing our inspection. Has it been installed so it actually works? So is it there and does it work? Really need to infiltrate our inspection technique and ask this question. So obviously if ducts are tied in a knot, that fan isn't going to work. It's not going to remove that moisture from that room. A crucial component of our compliance is not happening, so we should fail it and come back and re-inspect. Again, it can happen with insulation as well. We can't just walk into a house and see pink insulation in the stud cavities and walk out and say it's working. We need to ask that question. As it's installed, does it actually work? Are cavities being installed and being used as trash cans, or are they actually installed so that that insulation can trap the pocket of air and get the resistance, R value that's required by the code? Has our design been done well? And has it been executed well in the field? These are common issues that we see in the field that make it so that that HVAC design will not actually work and work in conjunction with the thermal envelope that's been provided there. Is it there? One last thing about insulation. Is it there and does it work? So we need to make sure that those are being taken care of. So the IECC has these code compliance pathways through the code. They also have mandatory requirements in the code, and that's the other thing that the inspection process needs to ensure that these mandatory requirements are happening out in the field. A lot of these mandatory requirements are detailed in this table. This is a mandatory table in the code. It breaks out the components, the air barrier criteria or mandatory requirements, and the installation criteria or mandatory requirements for the code. But there are other requirements in the code that are detailed out and are labeled as mandatory. These are requirements that must be met by every building unless there is a specific exception in the code. We have prescriptive requirements, and these are requirements that must be met by every building unless an approved trade-off is utilized or unless there is a specific exception in the code. And the reason to bring that up is that a lot of these prescriptive requirements where there is not an exception or there's not an R value talking about where you can trade off that R value or U value in a particular component, those prescriptive requirements become mandatory. And the code in the 2021 cycle is going to make that more clear. But right now, we need to understand that that prescriptive requirements are often mandatory requirements because the performance approach is talking about the ability to trade off items. And trade-offs only work with R values and U values. And the prescriptive section talks a lot more about other things, requirements, other than R values and U values. So for example, it talks about attic eave baffle installation. It doesn't say if I use the performance path that I don't have to install an attic eave baffle in a ventilated attic assembly. Regardless of the pathway, if I have a ventilated attic, I have to install attic eave baffles as required and dictated by the prescriptive section of the code. Same with crawl space vapor retarders. Same with the way that floor insulation and attic insulation installed. Yes, I can trade off the R values and U values in the performance paths of the code, but I can't trade off the way that that floor insulation is actually installed there. That's governed by the prescriptive/mandatory requirement of the code here. So in conclusion, we need to look at the required compliance reports, whether they're required at permitting or at completion, whether it's proposed or confirmed reports. We need to understand how to read them and ensure that we're reading them to issue our permits and our certificates of occupancy. Again, we're seeing some jurisdictions that are collecting the report, for example, the air leakage report, but not necessarily looking at the report and if it actually complies, and therefore they're issuing certificates of occupancy to houses that aren't meeting the air leakage requirement of the code. Field inspection needs to be married with these compliance reports in a lot of ways, especially that proposed compliance report. And we need to understand, is the component actually there? Have they installed the fan in the proper location? Has it been installed so it actually works? So this becomes a new mantra of this performance-based inspection process that we're trying to promote and get people to use more and more. And ultimately, if you can't inspect everything that the code is asking you to inspect, get these reports and use third parties to help you. But make sure you're on the same page with that third party, that everybody's making this code work and work well. If everybody's on the same page about what we're inspecting for, what we're looking for from compliance reports to construction reports to inspection when we're actually out there in the field. So thank you so much for spending a part of your morning with me today. I will definitely hang around and have some dialogue, answer any questions that came up. If you have to go, you have to go. But let's look and see if there are any questions.
Fantastic. Thanks so much, Robbie. Really very well done. Makes me need to go up my game on my energy code presentations. I've already answered about 6, just kind of as they've been scrolling in. Some of the simpler ones I've just kind of answered. I do have a handful more that have come in. As far as the registered design professional preparing the compliance documents, that is at the discretion of the code official. It rarely happens in Texas that a registered design professional has to do them. Now, like I said, Texas does have a state law where certainly you could require an IECC certified professional. Do you see it in Colorado that it's typically that an RDP does the compliance documents, or do the builders typically?
No. Well, first of all, if you look closely at the language, it doesn't say anything about the registered design professional having to create compliance documents. It's all about the true construction documents. So we point that out because we are not seeing registered design professionals create compliance documents at all, and in most cases, they don't want to be involved with that at all.
Yeah, that's kind of what we're seeing. And then I have a lot of jurisdictions, even on a straight prescriptive house, and just FYI for you code officials out there, like Robbie said, you don't need anything other than the cavity insulation and window values. If all of that's called out on the plans, and like Robbie said, you cannot go below ever, not even on a vault ceiling area. Well, it allows up to 500 square feet to go one insulation value down. But like HVAC walkways, you've got to fur those up. But you can always do a res check on a straight prescriptive job, and it will show that you pass. Just FYI on that. Oh, I did like, Robbie, that you mentioned that the compliance path is in the 2021 code, because that reminded me that you and I both submitted that as a code change proposal. So that made me happy to see that we were thinking along the same lines, and the ICC is getting that into the newer code. Now, I did have a question for you. I had always, so like here in Texas, and I had this question come in from Houston the other day, and I played with it and looked it up. So for instance, like in Texas, we'll typically have a 2x6 ceiling joist, and R38 is our requirement. So you could conceivably have R19 blown in between the joists, and then there's an additional R19 on top of that, somewhat continuous, because it's above the joist. My understanding, I used to have an understanding that could be entered as R19 cavity and R19 continuous in ResCheck. But a couple of weeks ago, I did a little digging on ResCheck, and it became apparent to me, and I can't remember exactly why, that R38 blown on top of a 2x6 ceiling joist cavity should be listed as R38 cavity, not split, because the continuous in ResCheck typically means for like a rigid air impermeable insulation. Can you expand on that? Do you know anything about that?
My understanding is different than yours, I guess. Although potentially continuous insulation generally has the connotation that it is rigid and is on kind of the exterior, because we almost always think about it on walls, exterior walls. But it's basically a modeling exercise, and it's regardless of the type of material that's being used. If it's continuous, it's continuous.
Right. The modeling is simply a U, which is just simply going to convert the inverse of the R, and it has nothing to do with air impermeability or any of those other things. If I'll do a little digging in ResCheck again, if I can find what made me think that it all needs to be entered as cavity, I'll shoot it over to you.
And you'll see a difference in your ResCheck calculation, because you have nothing impacting that thermal bridge of the truss if you enter it all as cavity, when in reality you do have a thermal break there.
That was my initial thinking, and that's how I initially taught it. And then I came across something the other day, and like I said, I'll do some digging, and if I come across it, I'll shoot it out to the attendees today.
Yeah. We can reach out to Pam Cole and get confirmation
off the top of her head. I've got a few more. As a plan reviewer, how can I get a copy of the energy pathway plan that I can share with our designers and require at plan review? You'll have a copy. Everyone on the webinar will get a copy of Robbie's PDF. I don't recall energy pathway plan. You know what he's talking about there, Robbie?
I'm not sure what he's talking about. Besides what's already in the code. In each section of the code, it tells you what's required for each pathway.
Yeah, and ResCheck and ComCheck do a pretty good job of making sure you dot all the I's and cross all the T's. And, if you really compare those to the plan set and make sure like equals like and they match, you really should be pretty good to go. Although I did one of the plan reviewers, City of Houston, sent me an email the other day, and a builder had actually, which Robbie makes a good point, double check these compliance documents, because literally they had submitted a ResCheck that was 6% below code, submitted it with the plan set, just like it was going, oh, we submitted the ResCheck, it meets the energy code. Well, no, not if it's 6% below.
Yeah, and I mean, it's a true thing that I was talking about with the air leakage one. We have a jurisdiction that collects the report, but doesn't look at it And we're at 3 air changes per hour here in our climate zone, and these houses were coming in at 4.5 or 5, and they're getting their COs.
That's crazy. And then another question, I do have, along with Robbie's PDF, I do have some third party. I had a question about scope of work document. North Central Texas COG has a good amendment to the code that talks about, I'll send some of that out. Bill asked that question. I'll send that out with Robbie's PDF as far as third party registration, third party scope of work. I'll send that out to you folks.
You send that to me as well?
Yeah, actually happy to. Stephen asked, do you provide a presentation for commercial installations, especially mechanical, electrical, and plumbing disciplines? I already owe him a couple of beers and a burger. I don't know how much, what else we can get out of Robbie. But they're already wanting more, though, Robbie, is the essence of that question. So the invitation is... I'm not as fluent with the commercial code, but I know people that provide similar type of presentation for the commercial. Right on. I'd love if they're home and not too terribly busy, I would love if they could. And I should be doing a commercial one before too terribly long. I do have a really good checklist on commercial that I'll go ahead and send with the PDF and everything else. I'll send it to you too, Robbie. It's City of San Antonio developed it. It's a phenomenal checklist to go along with commercial. Because ultimately, commercial projects can get so complicated that we have to put some of the onus on the engineers and designers to help us double check that stuff. Res check and residential, not in rim rate and all that, in my opinion, not typically, nowhere near the level of difficulty, and I don't think that's necessary. So I will send that out as well, Bill. Also says, thank you, great job. And then 3 more. In the Ecotrope software, you will see as part of the checklist that a manual J report is required. Would you say that it is required at permitted or at latest during inspection? Same for prescriptive appliance. I'll answer that in my opinion first, and then I'd like to be interested to get Robbie's opinion. Now, the energy code requires the design. It doesn't necessarily require a copy of the manual J at permit, but by energy code. But in my opinion, if I ever fall off the wagon and become a code official again, 5 years clean, no red tags, by the way, happy to announce. A copy of ACCA's residential system design review form would be required for all new residential construction. And in that ACCA residential system design review form, it incorporates elements of manual J, S, and D, and then requires all 3 to be attached to that 1-page form at permit. I think it's just oversizing HVAC systems in Texas is really, really rampant, and it's a problem. And 20 years ago, with that 500 square foot per ton, probably worked okay when we had no idea how leaky houses were, and they had crummy windows and less insulation. But in today's market, where we know exactly how much the ducts leak, exactly how leaky the house is, we've got really good windows, probably the biggest improvement. LEDs, things that emit light rather than heat, LED versus incandescent. That 500 square foot per ton rule of thumb doesn't work anymore. But, I also live in reality, and my dad's a carpenter. That's how I learned how to do construction. That's how I got in construction. Well, if I'm an HVAC contractor and my dad taught me how to do it, and it was 500 square foot per ton, and I've never done a manual J in my life, there's 3 questions from TDLR on my contractor exam. I don't even have to know how to do it. The jurisdiction doesn't require it. Well, I'm just going to keep putting that 4-ton unit in that 2,000 square foot house because that's what I'm comfortable with, and that's how I learned. Well, what's your opinion on manual J and its necessity at permit there, Robbie?
I agree with you. I think, some level of review of the manual J is crucial to happen at permit, and specifically because the thermal envelope is such a crucial part of that manual J. And if they're using different R values and U values than are actually being proposed in the house, that's a big issue. But if in the construction process, let's say an R19 bat is installed in the wall, but that bat, the way it's installed, again, is it there and does it work? The way it's installed is performing like an R10, that design will not work. It just fundamentally won't work. So we have to be able to we have to understand what they proposed, and that what they proposed is in relationship to what the architects proposed for the R values and U values. And then we have to make sure that it's not only there, but that it's working.
That's a great point. Great point. Well, that's all the questions. Thanks. Sorry, we're 20 minutes over. We did have some complaints last week about going over. Just so you know, I registered last week's ICC CEUs for an hour and a half. A lot of times I plan on going an hour. Sometimes I go an hour and a half, or sometimes I come up a little short. So just FYI, if you ever do need to hop off, don't worry about it. All of these go up on our YouTube channel. You can catch them on our YouTube channel. Please subscribe, by the way. If you are needing ICC CEUs, you will get a course evaluation after this. And again, with that course evaluation, I'll send those commercial documents that I mentioned. I'll send the third-party documents that I mentioned. I'll go ahead and include the PDF of my approved presentation and how it really needs to be approved in the code. And then I'll follow up with ResCheck and find out about that cavity versus continuous. And I'll keep you in the loop on all that, Robbie. Thanks so much for joining us this morning, everyone. And Robbie, special thanks to you. If you ever are willing to give another presentation for us, I'd be happy to have you, because that was really thorough and pleasing to the eye. Really well done, Robbie. I appreciate it this morning. Thanks, everyone. Y'all have a great day.
Thank you.